Okay, we are now live. Hello and welcome to this special webinar today. As you see, today we have our CTO Benjamin Bendig here and me, the CEO of MarketPeak. So today we will have a crypto webinar by Benjamin Bendig, and I want to do a short introduction because this crypto webinar is a very special one because normally only our members who bought at least $1,000 package, so the marketer package, can participate from such crypto webinars because education is one of the most biggest investments. I have my own experience in that. Without education, without the knowledge, you can lose so much money, but in other way you can gain so much money. Yeah, and that's exactly, if I knew much more, or I see how many people 2018 2019 lost money in the crypto space because they don't have the knowledge. They don't know that they're out there, for example, USDT, where they can switch and so on, where they can save their crypto and so on, and many other details. So yeah, therefore we have today a special webinar with Benjamin Bendig. And yeah, before I'm talking too much, I would say, Benjamin, the stage is yours and you can introduce yourself.
Thank you, Sergey, and welcome everybody to our first English language tech webinar. Happy to see how it goes. To just quickly answer a question that Step Bear asked. Heute nicht auf Deutsch, Wochenend-Webinare auf Englisch. Die Deutschen findest du nach wie vor auf Facebook allerdings. And with that, back to the topic. So yeah, we will start with the first webinar in the tech webinar series, and that will be an introduction to the whole topic in general. What is a blockchain in the first place? What is DLT, distributed ledger technologies? And then I'll show you a few examples. And the point of this is to give you just a bit of a better understanding, a deeper understanding in a simple to understand way though of the tech behind it, and to really make you grasp why it is such a great new thing and why I am of the opinion, and I'm not alone with this opinion, that DLT will definitely change the world about as much as the internet did. And exactly, when you have any questions, just post into the YouTube chat, and whenever I see them and have a good moment, then I'm happy to answer your questions. And with that, let's begin. I hope you can all hear me well. If you can't, please let me know. And yeah, if you can't see, also let me know, but I think it should be good. So, topics today. What is a blockchain actually? And we'll be using Bitcoin as an example for that, because everybody knows Bitcoin, right? We will talk about what is a distributed ledger technology, and I will give you a few examples of DLTs that are not blockchains. And if time at the end permits, then I will give a little peek into the future, things that we have planned and ideas for the decentralization of the MarketPeak platform itself. And with that, let's get started. So, what is a blockchain? Simply put, it's actually nothing else but just a special type of database. We had old school databases for decades now. Blockchains are just a database with one important difference though, and that is what makes it different to everything else that we had before, and that is trustless trust, a thing we could never have before. What do I mean with this, and how do we get through this? What I mean by trustless trust is you don't have to trust any entity or person or government, nothing, because there's no single entity or person that can change the data that is stored in this blockchain database. Very much unlike classical databases, where there's always someone, a database admin, for example, who has the access rights and permissions to just go in and literally change whatever he or she wants. And then that is what is in the database. That's not possible with the blockchain. And how is this? This is because of the following attributes that blockchains have. So one thing is blockchains are distributed. And that means the database is not just on one server, but instead it is distributed over a lot of computers and servers in the blockchain space. We usually call those nodes that are all around the world. What's the upside of a distributed system? Quite simply, imagine there's a fire or an earthquake or some other type of catastrophe, and that destroys the building that the server is in that contains the database. Now the database is gone and all the data is gone. That would be bad. If it is distributed, because it is then in multiple places at once, if one or even a few of those places go down for whatever reason or are cut off from the internet temporarily, whatever, it's not a problem. There's enough copies around of the data that you can still get at it. So this gives you a certain degree of security. And it also makes it harder to censor it or take it offline in other ways because there's more and more copies floating around. Then blockchains are also decentralized. Now you might be thinking, right, distributed, decentralized, that's kind of the same thing. They sound very similar, but in the crypto space, we use the terms quite differently actually, where the term distributed is used to really talk about the physical location of the data, not being in one place, but in multiple places and as spread out as possible. The term decentralized deals with the governance of the data and not actually with the level of distribution that it has. And what we mean by governance is who controls the data, who is able to say what is now the truth on the database, on the blockchain. And with the example of a classical database, let's take your bank account balance as an example. So the bank certainly has the power to change the number that is stored in the database, that is your bank account balance. You as a person, you don't. And you can make transactions and you can receive money, which will change that number. But you yourself, you cannot go into the database and change your balance. A malicious database admin could do that. And of course, the bank that owns the database also can do that. In a decentralized database, in a decentralized governed blockchain database, that's not possible because there is no single entity that can say, okay, we use this now as the truth. What you have with blockchains is you have all these miners, right? You certainly heard of that. And they have to mine blocks and verify them. And how this works in detail, we will get to in a moment. But what this does is it makes it so that the vast majority of the network has to agree on any change to the database, on any addition to the database. And the majority of the network has to agree that, using Bitcoin as an example, a transaction made from A to B actually was broadcast by party A, not by party B, the recipient. And for example, also that the amount sent is not bigger than the amount that is the balance of the sender, and stuff like that will be verified and confirmed by the network, as we say. And that is why not a single node, this or that, can just change the blockchain. How in detail, that we will get to it. Then data on the blockchain is very easily verifiable. It's very hard to mine a block successfully. I think you have heard about how much energy is put into Bitcoin mining. And the reason for that is that it's a lot of work to mine a block in Bitcoin these days. And thereby verifying the correctness of the data contained inside the block. But to verify it is extremely simple and has a very low cost in computation. And this means that if there is an event of manipulation, every node or even your wallet software on your computer or on your phone can very easily verify, oh, a moment, wait here, this must have been manipulated. Because basically the manipulated block and all the blocks following it will just wildly blink red, not literally, but to the miners and the wallet softwares, they will just basically scream, I have been manipulated. And because of that, they will just be rejected by the network and not be used. So this is the upside of having the, to have the data be so easily verifiable for correctness. Then we have irreversibility. You cannot make a transaction and later, after it has been successfully verified and mined and is now in the blockchain, you can later not take it back or undo it. What you would have to do if you made an accidental payment is you would have to ask the recipient of the payment to please be so kind and send the money back to you. And if that happens or not is no longer in your hand. The upside of this irreversibility, though, is that I cannot make a payment for a service, then receive this service, consume this service, for example, education, or any other things that you just consume one time and then they're done. And then I can do a chargeback, like with a credit card. That is just impossible on the blockchain. And it's also important to have this irreversibility to be sure that newer data is valid and makes sense with the older data. If you could just take something out that happened a few months ago, let's say you were able to just take a transaction out that happened a few months ago. Now the stored balances in the different addresses wouldn't make sense anymore because of this transaction that now didn't happen after all. And so to ensure correctness and make manipulation even harder, irreversibility is a must and is given. And all these four things together, they just make a really robust and incorruptible database that is next to impossible to censor or manipulate. And I think that's just great. And that is a thing that wasn't possible before. And now here is how blockchains actually manage to do this. Now, excuse me. Now, what's a blockchain? It's a chain of blocks. So much so clear, I guess, from the name. What is a block? A block is just an amount of data. There's just some data in a block. And sticking with Bitcoin as the example, either when the maximum block size is reached or every 10 minutes, and not less than 10 minutes in the case of Bitcoin also, the network will say, okay, all this data that has come in the last time, this is now a block. We put all these bits of data together in a block. What data is it? It could be anything. As I said, a blockchain is just a database. But in the case of Bitcoin and most cryptocurrencies, of course, the data that is stored is transaction data. So this is address XY sends this many Bitcoins to address Z. That is the type of data that we store in Bitcoin blocks. So let's imagine we have a bunch of transactions in a block. And now the time is up, the 10 minutes, and we want to mine this block now and verify it. So what happens is we add another piece of data to the block, the last piece of data, and that is the signature of the last block. Now, by signature, I'm talking about a cryptographic signature. Mathematically speaking, that is a hashing function. You can imagine a signature a bit like a digital fingerprint, and it has so these signatures and hashing functions, just very quickly, have the following behavior. They have a violently different output, even if you just have a very small change on the input. So for example, if you take the Game of Thrones books, all of them, and you make a hash out of them, a signature, you will get a long column of numbers and letters. Now, if you change a single letter in these thousands of pages, and then you get the signature for this, it will look nothing like the signature you got before, even though the data is nearly identical with just one single letter changed in thousands of pages. The signature will be wildly different. And this is why we can use them as a fingerprint, basically. So, you know, if the signature is different, the data must be different. Okay, now that we have the last block signature as the very last bit of data in the current block, we calculate the signature of this block. And then we start receiving new transaction requests, which we put into the following block. And again, the last bit of data in that following block is the signature of the block we just mined before. And again, we will form the signature of this block, which we again include in the next, and so on and so on. And by always including, this is a key point here, by always including the signature of the block that has gone before into the current one, we link these blocks up to each other. This is exactly how an amount of blocks gets turned and also ordered into a chain of blocks. This is how the blocks become a blockchain, by linking every block together with the signature of the block that has gone before. This is a very core concept, and yeah, that is really what makes this database a blockchain, together with the concept of having not one computer do this, but a network that competes to do this. But this is, simply put, how a blockchain works and why it is so tamper-proof. Now let's imagine in the leftmost block on screen, in the transaction number 2, let's say I've sent 0.1 Bitcoin to somebody. And now I think, you know what, would be better if I would have sent only 0.01. So I could try to change the data in this transaction and the data in this block. But if I do, the signature of the block won't fit. And I've mentioned before that it is very easy to verify the validity, by which I mean it's very easy to look at the data and the signature and look if the signature matches the data or not. Finding the signature, now that's tough work, that is mining. But verifying if the signature is true or not, very simple. So if I manipulate this transaction 2 in the leftmost block, then it will be screamingly obvious for all the nodes and the wallets that the signature doesn't match up anymore. But this now means that the block behind it also blinks up red, because now its signature isn't what it should be anymore. And because of that, the following block yet again has the same issue, that its signature doesn't match its data anymore. And this is what I meant when I said before that in any attempt of manipulation, the manipulated block and all that follow it will basically scream loudly, we have been manipulated, we have been, we are wrong, ignore us and throw us away, which is what the network will then actually do. It will just start to mine on a different fork of the blockchain. Disregard the word fork here, that's actually reserved for something else. But yeah, in that case, the part of the chain that has been proven as manipulated would just get ignored, and the mining would continue from the provably not yet manipulated part. And that's how the blockchain works on a very, very high level overview. There will be webinars where we go into a bit more detail. How exactly does a Bitcoin transaction work? How exactly do those signatures generated? What is that in more mathematical detail? But that is for other webinars. Now, distributed ledger technology. What is that? Isn't that basically the same thing as a blockchain? Fair thing to think that, and the terms are still used very much interchangeably by most people, even publications, admittedly, but no. DAT is actually, mathematically speaking, it's a superset, a superclass of blockchains. That means that, yes, every blockchain is distributed ledger technology, but not every distributed ledger technology is a blockchain. Just as every bicycle is a means of transportation, but not every means of transportation is a bicycle. There are cars, there are planes and others. And this kind of relationship is the relationship that blockchain and DAT have. Blockchain is just one type, one idea and interpretation of DAT. But there are lots of others. And these others, that's my personal opinion, and I have a terrible track record of predicting the future, but still I haven't been wrong all the time. I think that blockchain specifically is not actually going to be the future. DLT for sure is, but blockchain has these scalability issues that you've all heard of. This leads at times to extremely high transaction costs on Bitcoin. This has led, CryptoKitties comes to mind, this has led to huge holdups and extremely long waiting times for transactions on the Ethereum blockchain. Because yes, there is a maximum block size, that means a maximum amount of data, that means a maximum amount of transactions, and there is a maximum amount of blocks per time, or a fixed amount of blocks per time in most blockchains more exactly. And this means precisely that blockchains, unless they do some really fancy stuff, have an inbuilt limit on the number of transactions that they can handle per time. And that's a pretty low limit, actually. That is not a high limit. And this is why alternatives are looked for. And Ethereum, for example, is looking to be not just the blockchain, starting with Ethereum 2. And we will go into this just a bit also, a bit later. But yeah, a few other things, just a few ideas, and I'm sure not all, that are also distributed ledger technology are parallel blockchains, for example, that are a bit networked together, block lattices, yet another way of having parallel blockchains, let's say individual blockchains in that case, work together. And then we have things that aren't even blockchains at all, not even in some combined way, like the DAGs. And yeah, all the question marks stand for things that I personally haven't heard of, and they stand for things that haven't even been thought up yet. So I'm absolutely sure that there will come interpretations and ideas on how to do a DLT that nobody has thought of yet. They are not yet born, these ideas, and I'm super excited to see what the future will bring for that. So let's get into a few examples for DLTs that are not blockchains. And I left a German word on that slide. Excuse me, Beispiel just means example. My bad. Overlooked that when translating the slides. So IOTA, or IOTA, however you want to spell it, it's pretty well known for people that have had an eye on the crypto scene at least. And IOTA, they are collaborating with Bosch and some car and electric companies. And they want to be for the Internet of Things. That's where the IoT in the name of IOTA comes from. It's supposed to be the payment currency and method, for example, for electric cars that just plug in somewhere on the road and recharge and pay the recharge right away with cryptocurrency. And IOTA wants to be this. Now, what is so interesting about IOTA? That's the following. All the blocks that you see here are, so the squares to be precise, those squares aren't blocks. Those squares are individual single transactions. And that is a big difference already compared to a classical blockchain like Bitcoin, for example. Where in Bitcoin we have as the unit that we really care about, we have the block and the transactions are just in it. Now, the units that we care about in IOTA are the transactions. So there is not even the concept of a block in IOTA at all, which is special. And now let's try to understand this graph here. Every square on this graph, oh, by the way, yeah, IOTA calls their structure a tangle. Mathematically speaking, it's a DAG, a directed acyclic graph, but you are free to forget this right away. That's not that important. Just wanted to mention for completeness sake. So let's look at a gray transaction on the right. What you see is that those gray transactions have two arrows to two red transactions. Now, what do the arrows mean? The arrows are the transactions that the sender of the current transactions has confirmed with his own computing power on his own device. And that is The, I think, really cool idea behind IOTA is you don't even have miners. You don't only not have blocks, you don't even have a miner at all. What you do is every time you want to make a transaction, you have to spend the computing power. It's not that much. A smartphone or an old laptop is enough, so you don't need a big computer to do it. But still, you yourself have to invest the computing power and to confirm two other transactions. And by this, basically, you pay for that transaction. Now, what is the big upside of this? Maybe let me explain the colors first. So the gray transactions are transactions that have been confirmed 0 times. You see no incoming errors to the gray transactions. That's why they're gray. The red transactions have been confirmed 1 or more times, but not enough times to be really judged as confirmed by the network. So the reds are, yes, they are somewhat confirmed, but not confirmed enough. And the green transactions are those that have been confirmed more than X times. Looking at it, it looks like X is 4 here. So every transaction that has at least 4 transactions confirming it is then judged as confirmed properly. So this is what this is. Yeah, what is the big upside of this idea compared to a classical blockchain idea like Bitcoin or Ethereum as the maybe most prominent examples? And that is that the more users you have, the more incoming transactions per time you have with this system, the faster you are able to confirm transactions, because the more incoming transactions you have, the more people need to confirm other people's transactions to get their own transactions into the network. And that's the big difference. In a classical blockchain, the more users you have, the slower everything gets. And then there's a hard cap over which it will just not work anymore. And this doesn't exist. So that is why this is a really smart idea. Classical blockchain, more and more users means everything gets slower and slower. In this tangle, as IOTA calls it, more and more users mean everything gets faster and faster. And that's a huge difference. And that's a really clever idea. Now, will IOTA be here to stay for 10 or 20 years? I don't know. But the idea, at least, that is interesting. Another example for a DLT that is not a classical blockchain is what Nano, they have been called Reiblocks before, they renamed to Nano, what they call a block lattice. And now a block lattice is, they just call it like that. I like to explain this like follows. Every user of Nano gets his own or her own personal blockchain. So you have a blockchain, you have a blockchain, you have a blockchain, I have a blockchain. If let's say I am user A and you are user C. If I want to send a transaction to you now, how does this work in this system? I have my own blockchain, you have your own blockchain. And then there's some interchain communication going on. But if I am user A and you are user C, and then I want to send you a transaction, we can see on the blockchain of user A, this S on the lowest case. The S stands for a sending transaction. And this means I publish to my own blockchain a sending transaction. And that just means I want to send this many Nano to this recipient. Now then the cross-chain communication, we're not going into that, it's just there, will then inform the recipient's blockchain, hey you, there is an incoming transaction on another blockchain. There is a sending transaction to you on another blockchain. Would you like to receive this? So then, of course, the wallet will automatically say, yes, I would like to receive it. Of course, why not? And then the recipient, which is his wallet software, of course, you don't do that by hand. That should be obvious. But the recipient then, C in this case, creates a corresponding receiving transaction to my sending transaction. And as soon as both of these transactions are on our respective blockchains, then the Nano has been transferred. And now user C has it, and I don't anymore as user A. This is why you see these arrows from the S transactions, the sending transactions, to the receiving transactions. And what's the upside of this? Again, it really doesn't matter how many transactions happen per time. it really doesn't matter how many users at the same time are using the Nano network, because it just doesn't, it quite frankly doesn't matter. If there is 10 other users or 10 million other users, that just has zero impact. That's not 100% true, but it's true enough. Has just zero impact on my blockchain A and your blockchain C and our ability to transact between each other. And so that is yet another way to avoid the scaling trap or the scalability issues that are pretty much inherent in basic classical blockchains, and also an interesting concept. Of course, the cross-chain communication, cross-chain validation is not in here. There is some overhead, but it's still, there is no hard limit on scalability with this idea and concept, as there is with the classical blockchain. And another example is the Ethereum sharding plan. So Ethereum is the most used smart contract platform because it was designed to be a smart contract platform first, very much unlike Bitcoin. And this has meant that, and still to this day, it's just so much easier to do anything that isn't just transferring currency on Ethereum than it is on Bitcoin. And it is the most adopted and most experimented upon smart contract platform. By the way, smart contract platform is basically just a blockchain system that allows execution of code on the blockchain instead of just storing data on the blockchain. There will be another webinar going into that in more detail, but that's just on the side. So Ethereum is basically number one currently and has been for years when it comes to anything involving smart contracts. That also means tokens, which are not the same as cryptocurrencies, quite different actually. Yet again, that difference will be explained in another webinar. But Ethereum is currently in a really, really, really good position in the market, and Ethereum wants to keep that. But the people making Ethereum are really smart, and that means they're smart enough to realize we are a classical blockchain. We have hard upper limits on scalability, on number of users, numbers of transactions per second. And if you're not only transferring currency, but you're allowing your blockchain to be used for all kinds of things and calculations, then a transaction isn't even just sending money from A to B. A transaction is also, I interact with a smart contract. So they have way more transactions over time than Bitcoin has. And they know if we really get adopted by the masses, we will not be able to scale. And basically, if they get successful, then they can't be successful. So that there really is a hard catch-22. They want to become big, but they can't, technically speaking, although right now they're number one. So they know, and that's what I was getting at, they know they need to do something to scale. That is the single most important thing for the future of Ethereum is scalability. And they're very well aware of that. And so one thing that they are working on implementing, starting with Ethereum 2, is the concept that they call sharding. Now, imagine parallel blockchains. To explain this picture a bit more, right? Every transaction that we store in a block is just a piece of data. Data in computers is in the end numbers. And that means that every bit of every transaction can be represented as just one long number. That is your transaction for the computers, and for the blockchains, it is one super long number. And that goes for every text and image on your computer too, but that's just on the side. But that every transaction is a number allows us to sort these, because some transactions will start with the number 1 as their first digit of the whole number. Some transactions will have the 2 as the first digit, some the 3, and so on. So that means we can, and this is exactly what sharding will start out doing on Ethereum. They will just have 10 blockchains and say every transaction that starts with a 0 goes to this blockchain. Every transaction that starts with a 1 goes to this blockchain, and every with a 2 to this, and so on and so on. So they have 10 times as many blockchains with, on average, only 1/10 of the amount of transactions per time per blockchain. And that's exactly why this is a good idea, because on one single blockchain, every single node has to do the work and agree. That is a bit sloppy formulated, but it's good enough to make the point. Basically, every computer on one blockchain has to deal with every transaction, and it's a bit of a waste of computing power. Now, if we split these computers up over 10 different blockchains, then all of these computers will have only 1/10 of the workload. And that is why that is a good idea, because we will be able to now have about 10 times as many transactions over time, because we have split it up quite simply. There is a bit of overhead, of course, so it won't be exactly a 10x increase of possible transactions per second, because of course the different blockchains will have to talk with each other. There will be transactions that go from one chain to the other, and then there has to be not only cross-chain transactions and communication, but also validation. So there will be an overhead layer. Maybe I am making this up a bit, but maybe it will be with 10 blockchains plus the management layer overhead. Maybe it will be 8 times as performant and as scalable as it is on a single blockchain. In any case, it's a big improvement. And of course, this idea can be further split up in the future. So they could, in theory, at any time decide to not split into 10 chains, but into 100 chains, to then again nearly 10x their scalability. Ethereum is also working on yet other ideas to increase scalability, but the sharding is the one that is most likely going to be implemented first. And that is where I think the future will be going, is to either any of these or even one of these question marks. It's hard to say. I'm curious what will come. But I'm definitely of the opinion that whichever precise implementation will win out, but for sure will distributed ledger technology change the world as the internet has done. There's no doubt in my mind about this. I think that right now the whole blockchain and distributed ledger space is where the internet space was even before the dot-com bubble burst in 2001. So I think we're that early still in blockchain. It's just becoming mainstream. It's just becoming a thing that people know exists, as was the internet before the 2000s. So in my prediction, there will be some big bubble burst and some in a few years. And the best projects of today will survive it. And most things that exist today will not survive it. But that's also pretty clear, because who needs 10,000 tokens that literally do the same thing, for an example? Who needs 100 companies doing the very same thing on the very same blockchain, and so on? So there's just a lot of things that won't survive. But in general, I am very excited to see what happens there. And I would bet money that, it will change the world just as the internet did. And today, we can't even imagine a world without internet. It seems ridiculous today, although it's basically 20 years old for the mainstream, really. Just 20 years, and it completely changed everything. It's going to be the same with the DLT, I swear it. Which one? We will see. I am excited. And now, because I didn't take that long, I still can have enough time to give you a little view into the future of the decentralization that we dream of for the MarketPeak platform itself. And remember, decentralization is about governance. It's about who controls and who decides things. Decentralization is not about being distributed. So this is about the governance that we want to decentralize in the best sense of the word in the crypto space. What are we thinking about? First, most obvious thing, of course, we would like to have all monetary transactions on the platform be transactions on the blockchain. So that just seems a natural thing, really, for a platform to invest into tokenized assets. And also, maybe that's just me, but maybe also just wants to push the whole crypto and DLT idea even more into the mainstream in general. Then a thing that I find pretty exciting, and I think you should find exciting too, because it will allow you to just not even trust us at all anymore. I mean, it'd be great if you did, but when we have implemented this, what I will just, which I will say in just a moment, you literally do not need to trust us anymore, and not even having to trust. I personally love that. What am I talking about? What I'm talking about is putting the whole affiliate structure and the whole reward structure into smart contracts on the blockchain. And these smart contracts will then manage the rewards, calculate the rewards, and also disperse them. And I personally just love it, because then we can tell you, if you do this, you will get that. And you don't have to take our word for it. You can literally look at the smart contract code, maybe not you yourself, admittedly, but it's possible in theory. If you can't read it, then, I mean, you could pay somebody to tell you, yes, that's actually doing what they say it's doing. But that's the thing. In theory, you can look yourself at the code and you can see, yes, actually, I can see right here, if this happens, then I will get that. And because it is a smart contract that is on the blockchain, even we are just literally unable to do anything about it. Like, even if we wanted to defraud you, we literally couldn't, because of technical reasons. And I personally, as a techie and a bit of a crypto scene enthusiast, maybe a privacy and data protection enthusiast, I love that. I think that's really cool. And this also is just a big increase in transparency, because you can see all the transactions happening, unless there's reasons to hide them, but that is something for the very far future. You will be able to actually verify, yes, this did come in, yes, this much I did get out, and so on. And another thing that we want to do is to really decentralize. Yeah, I think that's really where the governance gets decentralized. And that is give members the opportunity to use, for example, Peak token directly to vote on new features that they want for the platform. If there's multiple new features that could be added, why not give you, the users, the opportunity to decide which of these, or to vote for which of these are most important for you right now, which of these would have the most impact for you personally and give you the best way to work from then on. And another thing that could be up for a vote is, which new projects should we try to get onto our platform to tokenize an investment into. And both of these things can be done by basically having different smart contracts for the different platform features or potential projects that we're evaluating. And then you can just send tokens to the contract for project A or project B or project C. And then in the end, we can say, when a certain time is up, every new project that got over X tokens will join the platform. Or we can say the project that has got the most votes in the form of tokens will be the one that we choose. And then after the voting is done, of course, you get your tokens back that they have just been used for voting. But it is also a way to basically put your money where your mouth is, which makes people make better decisions, for sure. And then we are also planning, this is not around the corner though, but we are also working on a DeFi platform, a decentralized finance platform, on which you could use the Peak token as collateral as well. So that's just some examples of the things we have in our heads, some examples of the things that we want to go for in the future. And with this, I am actually at the end of my presentation. Current status is we have released our tokens, are listed on some exchanges. I'm not even quite sure which I can talk about, so I just won't. But we are. You can see our deployed token contract on Etherscan. You can see it on GitHub. And yeah, so much from me. I think that is it from my end for the first webinar. If you have any more questions, any feedback, wishes for the future, whatever comes to your mind, then I am looking at the chat right now.
Yeah, thank you very much, Benjamin. And it was again a very amazing webinar. And I think a lot of these people who listened now, they know much more about blockchain, DLT, and the use cases. So yeah, if you like that, then leave a like on this video. And also, if somebody could not attend right now, he can watch under this link the record of this video, the record of this webinar. And yeah, so this expect you. So you need to know that Benjamin will do every week from now a webinar for our members. Yeah, and every member who invested at least our $1,000 package, where you also on top get our software for minting peak token. There you have the access to all webinars from Benjamin. And yeah, he will explain a lot of more stuff about crypto. That was just the beginning, and it goes more and more deeply, and it will bring you much more for the future. So yeah, so you need you that was just yeah, I don't find the word, Benjamin. It was just a taste, yeah, a taste for that. And yeah, so um I don't know, do we have open questions now in the webinar, in the comments? No, I see.
Not so far, but
Hello.
thank you, Mr. P, for your lovely feedback. Glad you liked it. That's always nice to hear. Thanks.
Yeah, so thank you very much, and I would say have a great weekend, and we'll see us in the next webinars as members. So stay tuned. Bye bye, everyone.
I will, I know I can't. So yeah,
Yeah,
exactly.
you can also. It's still live.
Yeah, goodbye, everybody. Have a great weekend, and I hope to see you again next week. I hope you liked it. Ciao,
Great.
ciao.
Bye.